In this video, we're going to have a look at non-homogeneous second order differential equations, and how we know this is non-homogeneous is the right hand side is not equal to 0. It's actually equal to an algebraic function, and later we're going to go into why that's important. Now, the general solution for a non-homogeneous equation is always the complementary function plus the particular integral function. Let's first break down the complementary function. In order to do that, we need to form an auxiliary equation where we make m equal to dy dx. If that's the case, then m squared would be the second differential of y, so that's d squared y over dx squared. Replacing this equation with the auxiliary equation, we get m squared minus 8m plus 16 is all equal to 0. You always make the right hand side equal 0 for an auxiliary equation. Now, when you're solving this, you actually end up with complete the square form, but you end up with m minus 4 all squared equals 0, in which case there's only one solution, m equals 4, and this is what we call a repeated root. Now, where there's a repeated root, we say that the complementary function is in the form ax plus b all to the power of, multiplied by e all to the power of mx. In this case, we already know the value of m, the repeated factor, is 4, so we can just replace it with e to the power of 4x. By the way, a and b are just constants that we're unable to find right now. If it gave us values of x and y and dy dx, then we can substitute those later on to find a and b, but this question doesn't really give that. Now that we have the complementary function, I'm just going to highlight that, and in a different color pen, we're now going to focus on finding the particular integral, which most students find most difficult. Now, I've written this section here, but let's break it down. What it means is that for the particular integral that you want to try, go back to the pen, but let's make it purple. For the particular integral that you want to try, the highest order of power has to match the highest order of power on the right hand side. Now, the reason why we introduce, there is of course going to be the power of 0 that we have to add on to that, because we have to keep going in descending order until we end up at that constant value. Now, the reason why we go to that power is because if we differentiate y, well, that's not going to give a power of x, but this will give a power of x, 16y, because you're going to have 16 times ax, and then you can compare it to the right hand side. So let's now substitute that in. But before we do, the first differential of y is just a, and the second differential is just the differential of a constant, which is 0. Putting that into this equation, we have 0, which I'm not even going to include, minus 8 times dy dx, which is minus 8a, plus 16 lots of y. So that's 16ax plus 16b. And that's all equal to 4x, which is the right side of the equation. Okay, now matching this up, first of all, looking at the coefficients of x, we can say that 16a is all equal to 4. So let's write that out. 16a equals 4. We can divide both sides by 16 to get that a is equal to 4 over 16, which is just 1/4. So let's write that out. 1 over 4. Moving on now, if we compare the constants, we can see there is no constant on this side, so it's just equal to 0. And minus 8a plus 16b, they're all constants, so we can form the equation minus 8a plus 16b is equal to 0. Add 8a to both sides, you get 16b equals 8a. Divide both sides by 8, you get 2b equals a. Just erase that. And then, in which case, b is just going to be half of a. So it's going to be half of 1/4, which is an 8. Now that we've got values of a and b, we can say that the particular integral, I just realized that I introduced a and b before, but we don't know for sure that these constants are the same. So what I should have done is written at least like a2, just to make sure that it's different from these constants. Let's call these a1 and b1, and these a2 and b2. Do be careful of that in an exam. I have seen marks being knocked down for that. Sorry about that. If you commented that I made a mistake, you can erase that comment now. Okay, we have 1/4 x and then plus an 8th. Now that we have the particular integral and the complementary function, we can say that the function y is just the sum of those. So a1x plus b e to the power of 4x, b1 e to the 4x. Unfortunately, we don't have enough values to get a and b. Normally, in a question where you'd need to find a and b, it would give extra bit of information saying when x is this, y is this, and dy dx is this. Sounds like I'm just saying a whole lot of nonsense, but I'll make an example video, and when I do, I'll link in the description. But yeah, this is your answer to the general solution of this differential equation. Thanks for watching. If the video helped, be sure to like and subscribe. I appreciate it a lot. Thanks for watching your video. I hope it helped. If you have any tutoring inquiries for A-Level Further Maths, be sure to hit my website up at www.excelineducation.co.uk.